Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know about probability for the upcoming exam. So all that we learned was centered on conditional probability. So we read this probability of A given B. So B is a condition. We're saying B, an event has to happen. On the condition that B happens, what is the probability of A? So you can use this conditional probability formula. Probability that A happens, given that B happens, is the probability both happen over the probability of the second. Whichever one's listed second here goes on the bottom. Because sometimes an event happening affects the probability something else will happen. So for example, if I pick a card from a normal deck, if I tell you the card is red, that increases the chance that it's hearts. So those probabilities affect each other. We call them dependent events. On the other hand, if I toss a coin and get 3 heads in a row, that doesn't affect the chances that I will then get a head the next go. Those events are independent. So sometimes an event happening will affect the probability that another event happens. So let's look at an example here. Suppose that 30% of our students study biology, 25% study chemistry. We're told probability of C given B is 0.8, and we're going to calculate these. Now, when the question involves 2 sets, so here the sets are students who study biology, that's one set, and students who study chemistry is a second set. So when it has 2 sets, you should use a Venn diagram or two-way table. I think a two-way table is easier when it talks about the total, but you could just as easily use a Venn diagram for this. Now, Venn diagrams and two-way tables do literally the same thing. Their only purpose is to display information about 2 sets. So there are 2 ways that students can be. They can either take biology or not take biology. That symbol means complement or not. And then C and C dash, they can either take chemistry or not chemistry. So two-way tables have a row and column for total. That's why I said it's easier to use them when you're dealing with totals. Okay, so we're told that 30% of our students study biology. So I'll put 30 there. Because it's percentages, they need to add up to 100. So if 30% study biology, 70% don't. Similarly, 25% study chemistry, which means 75% don't. Okay, we need to fill out these 4 numbers, and we can get that from this. So this says the probability someone studies chemistry given that they study biology is 80%. In other words, of the students who study biology, 80% of them also study chemistry. Now, of these 30%, 80 study chemistry. 80% of 30 is 24. 0.8 times 30. So if that number's 24, it must be a 6 there, a 1 there, and a 69 there. So we've drawn up the two-way table. We now have displayed our information conveniently, and it will make these 2 calculations much easier. So let's look at the probability of B given C. So we can use the formula or common sense. The formula says if we want to find this probability, it will be the probability of both over the probability of the second. Whichever one's listed second is the one that goes second. So B and C is this cell here. There are 24 or 24% of students studying that, and that's out of 25 chemistry students. Another way you can look at it, there are 25 choices for chemistry, 24 of them study biology, so it's 24 over 25 or 0.96. The other one I'll just use the common sense. This is the probability someone does not study chemistry given that they don't study biology. So I know they don't study biology. I'm restricting my attention to these students. I'm only picking from those students. So for students who don't study biology, there are 70 such choices. Of those 70 choices, 69 of them don't study chemistry. So it's going to be 69 over 70. All right, let's now look more at independent events. So more commonsensical, 2 events are independent if they don't affect the chances of each other. So mathematically we write it like this. If two events are independent, probability A given B equals probability of A. The condition that B happens does not change the probability A happens. That's what it means to be independent. Now, it turns out if events are independent, there's this very useful formula here. If A and B are independent, the probability they both happen is just the product of their respective probabilities. That really comes in handy for questions like this one. I toss a coin 8 times, calculate the probability that I toss no more than one tail. So no more than one tail means I want to have either 0 tails or 1 tail. Okay, let's calculate these probabilities. So the probability that I toss 0 tails, that means I get 8 heads in a row. Now, each coin toss is independent. Doesn't matter whether you got heads or tails on the previous toss, because that doesn't affect the chances of what you'll get on the next toss. So the probability that you get heads on the first go is a half. The probability you get heads on the second go is a half. The probability of heads on the third go is a half, and so on. Obviously, a quick way to do this, we're multiplying a half 8 times. So why am I multiplying these probabilities? Because they're independent. The probability you get a heads and then another heads and then another heads and so on, I can just multiply their respective probabilities. That's what this formula allows me to do. So 1 over 2 to the power of 8 is 1 over 256. What's the probability I get one tail? Well, the probability you get a tail and then the rest heads is simply half times a half times a half. It's the same thing. It has probability 1 over 256. But hang on again. There are other ways I can get one tail. I could get the tail first, second, third, fourth, fifth, sixth, seventh, or eighth. There's 8 different ways that I could get a tail and 7 heads. Now, each of those 8 ways would have probability 1 over 256. The probability I get tail second would be the same. Half times a half times a half, 8 times. So there are 8 ways it can occur. The probability of getting one tail is therefore 8 times 1 over 256. It's 8 over 256. So the probability that either of them happens, the probability I get 0 tails or 1 tail. Now notice that these two are mutually exclusive. You can't have both. If you toss a coin 8 times, you can't simultaneously get 0 tails and 1 tail. So if two events are mutually exclusive, meaning they can't both happen, the probability this or this happens is just the sum of their probabilities. So that's the probability of getting 1 tail plus the probability of getting no tails, and the final answer is just 9 over 256. All right, let's look at one more question. So the OR rule tells us probability of A or B equals the sum of their probabilities minus the probability of both. So this is where A and B are not mutually exclusive. They can both happen. So let's use the OR rule to solve these problems. So we're going to calculate probability of A given B. If probability of A is 0.6, B is 0.5, and probability of A or B is 0.94. Now we know from the previous slide the probability of A given B is the probability of both over the probability of the second. So let's use this OR rule to find probability of A and B. So we have probability of A or B equals probability of A plus probability of B minus the probability of both. So we can simply rearrange this. We get 0.94 equals 1.1 minus that. So it has to be 0.16. The probability of both has to be 0.16 because 0.6 plus 0.5 minus 0.16 is 0.94. So therefore, the probability of A given B is simply the probability that both occur divided by the probability B occurs, which is 0.32. All right, let's do this one. We're going to calculate probability of A or B if probability of A and B are both 0.8 and A and B are independent. So probability of A or B equals probability of A plus probability of B minus the probability of both. As we saw in the previous slide, if A and B are independent, the probability both happen is just their two probabilities multiplied together. So the probability here of A and B will just be probability of A times probability of B. You can only do that when A and B are independent. So if you put that in your calculator, you get 0.96 and we're done. All right, thank you so much for tuning into this video. Best of luck studying, but you'll ace it, you're a star. This has been the luckiest maths teacher in the world. Have a great day.